What's going on, everybody? In this video, we're going to be doing 25 harder SAT problems. Now, a couple things to note before we start. These are not 25 of the most difficult possible imaginable SAT problems. These are 25 problems that I think are a little bit harder than average, and they generally can't be solved in like 5 seconds. And they're on a lot of topics that students struggle with, or they just look really gross and they'll freak a lot of people out. Now, I also want to note that the calculator problems in this video are marked with a C in the top right. You'll be able to see that, and non-calculator problems won't have anything. Also, the timestamps for each of these problems are in the play bar, and that's important to note because I'm going to be going into a lot of depth on some of these problems, and for some of these problems, I'll be explaining multiple ways to solve them. And so maybe if you feel good with that, if you understand the problem, you might want to skip ahead, and that's how you can do it. Also, if you're looking for the problem sheet or the answer key for this video, just so you have something to use to review for this video, that is going to be available in the description. And I know you guys are going to get questions during this video, maybe that I won't be able to get to in this video, and no matter how silly you think the question is, please ask it and I'll try to get to it when I can. Worst case scenario, somebody just comments something and they're like, man, how do you not know that, or whatever, and then I'll just bring down the ban hammer on them and I'll answer your question. Okay, so that's how I plan on policing the comments. And I also want to mention that my full SAT course is in the description. I'll talk about that a little bit more later. So yeah, without further ado, let's get into the first 5 problems for this video. And I do recommend doing these problems in sets of 5 because then after each set you can take a break. It helps prevent burnout, and you're really not going to be able to do all 25 of these problems in like one sitting, unless I guess you're cramming for your SAT the night before, in which case I guess just go for it. Do all 25. Let's get started. So we're going to start off with a few warm-up problems here, and the first of which says, which of the following is equivalent to 9 to the 3 over 4? Now for this one, it looks like just some simple fractional exponent problem, just no power over root, but you'll see it gets a little more complicated than that. So first off, what do we do when we see a fraction in the exponent? Because that's a little weird. Well, when we see a fraction in the exponent, we need to be thinking power over root. And by that, I mean that the power here is 3 and the root is 4. So what we can do is we can write this as 9 to the 3rd power 4th rooted. And alternatively, this is something, I don't know how many people just realize this, but you can also write this with the root first. You can do 9, again, right, 9's the base, have that be 4th rooted, and then do the cube after. You can do that either way. You can either do the power first or the root first. It doesn't really matter. And sometimes the root first is going to be nice to help simplify when you do these fractional exponent problems anyway. So you can either write it like this or like this, but in either case, you'll see here that that doesn't match up with our answer choices here. When we have 9 in the radical, it's either the cube root of 9 or the 4th root of 9, but here we have the 4th root of 9 cubed. So that doesn't match up. And so we know the answer can't be choices A or B. So is it C or D? Well, we need to get a 3 under the radical to try to figure that out. And so how do we get a 3 under the radical? Well, what we can do is I'm going to change this 9 to the 3 over 4. I'm going to still have it to the 3 over 4 power, but instead of writing a 9, I'm going to change that 9 and I'm going to write it as 3 squared. Okay, this thing is still equal to 9 here. 3 squared is 9, of course. So we haven't changed the actual value. Like, these things are still equal. But by doing that, I now have a 3 as the base. Right? Previously, 9 was the base. Now we have 3 as the base, and that means 3 is going to be the thing under the radical here. And you'll see that as we go along. So what do we do? How do we simplify this, make this look a lot less gross? Because we have a power to a power here. Well, when we have a power to a power, we multiply those exponents. And so we have 3 to the 2 times 3/4. And what's 2 times 3/4? Well, this 2 becomes a 1, this 4 becomes a 2, and we get 3 halves. So we get a 3 to the 3 halves. And already you know this isn't going to be choice C and this is going to be choice D. Because, and just circling my answer in red here, because rad 3, what's rad 3 written as a fractional exponent? Rad 3 is 3 to the 1/2, right? And why is that, if you're kind of confused on that? Well, power over root, right? 3 is to the first power, and it is second rooted. So first off, 3 to the first power is just 3. And a second root, when we have a second root, that's just a square root. Okay, where do you think the square root comes from? The square part? It's literally a second root. So the 3 to the 1/2 power is just the square root of 3. Now, a 3 to the 3/2 power, and I think it's good to just remember this, anything that's to the 3/2 power, you can write as that thing times the square root of that thing. So this can be written as 3 rad 3. But of course, I'll show you why that is. Where does that even come from? There's a couple of ways I can show you. Maybe one will be easier for you to understand than the other. First, I'll do it in radical form. So I'll write this with power over root. So if I write 3 to the 3/2 with power over root, this is 3 to the third power square rooted, or second rooted, same thing. Now, to simplify this, what I can do is I can break this up, just like simplifying a regular radical. What I want to do is I want to take out the largest perfect square, which is the largest number I can take out of that radical and get something nice. So what's that largest number? Well, that largest number is going to be 3 squared. And then this other number would be 3 to the first power. So 3 to the second power times 3 to the first power is 3 to the third power. We're good. Like, that's fine. We can split this up into these two numbers. But what does this square root of 3 squared do? Well, the square root cancels out with the square, and you get 3 here. This is the square root of 3, and so this is 3 rad 3. So that's one way that you can see it. But let's say that that was a little confusing for you, or you just want a different way of seeing it, and I think this will help also with some of your exponent rule stuff. You can write 3 to the 3/2 as a 3 to the 2 over 2 times 3 to the 1/2. And how did I know to write that? Well, because if I take out a 2 over 2, or just something that'll end up being 1, then this ends up being a 3 to the first power, right? This is just 1. And then this is a square root of 3. So this is, again, 3 rad 3. So similarly, if I was trying to split up 3 to the 5/2 power, I could write this as 3 to the 4 over 2 times 3 to the 1 over 2. And I just take out like the largest whole number. I think that's a better way of putting it. I'm taking out the largest whole number. Here that was 1. And now here this is 2. So this is a 3 squared times this is rad 3. So this is 9 rad 3. And so there's different ways that we can go about this. But yeah, I wanted to really show you and get you comfortable with your exponent rules, because I feel like a lot of people aren't, and then that kills them on the SAT. So I tried to go over as much as I could with just this problem. So now let's move on to the next one. All right, problem 2. If f of x is 5x squared minus 3, and f of x plus a is 5x squared plus 30x plus 42, what's the value of a? And so I think a lot of people run into a problem like this and they get immediately confused. They're like, well, what's this x plus a doing here? What's even going on in this problem? So, and I was there too. Like, that's exactly what I was thinking. That's why I know that. So let me explain. All right, we have f of x, and we're given that it's 5x squared minus 3. But then what we do is we add this a to the input, to this guy's the input, right? Let me get a smaller highlighter. So yeah, there we go. That's called the input. And when we add this a to the input, it changes the value of our function from 5x squared minus 3 to 5x squared plus 30x plus 42. And so naturally the question you would ask is, well, what was that a that we added to the input? What changed the function from this guy to this guy? What caused that transformation to happen? And so we can actually find out by doing that transformation ourselves. We take this x and we're going to replace it with an x plus a. And so everywhere in this function that we see an x, we're going to put an x plus a. So instead of having an x squared, we're going to get an x plus a squared. So I took this x and I substituted in an x plus a. Then I'm going to subtract the 3 because of course that was there too. So now what I'm going to do is I'm going to multiply this out. I'm going to write x plus a squared. We know that that is x plus a times x plus a. And then we have our minus 3. I know that this is equal to this because when you square something, you multiply it twice. Just like 3 squared is 3 times 3. If you replace that 3 with an x plus a squared is x plus a times x plus a. And so, let's multiply this out. I get a 5 times x squared plus ax plus another ax plus a squared. And then this is subtracted by 3. I can combine like terms here. That would give me 2ax because there's 2 ax's. And I get 5 times x squared plus 2ax plus a squared minus 3. Then I'll distribute through the 5. And I'll get 5x squared plus 10ax plus 5a squared minus 3. I have a feeling I was writing a lot. I was writing very fast there. Sorry. But that does bring me to an important point here. And that was that obviously I spent a lot of time expanding this x plus a squared into this. And what you'll see is that a lot of people already know that those two things are equal. And that is a huge hack that I would hope that you would memorize for the SAT because it will really help you speed up in a lot of cases. And so let's talk a little bit about that. So from doing this enough, what I can tell you is that if you have any like x plus y squared, this is going to be equal to x squared plus 2xy times y squared. This is something you'd want to memorize because you see this an awful lot. And notice that this is exactly what we just did here, but instead of having a I put a y. Similarly, if you have x minus y squared, here's another thing you'd want to memorize. This is x squared and then a plus y squared. Those two things are the same, but the only thing that's different, you still have a 2x minus y here, or sorry, a 2xy, but this is minus. So that's the only difference, is this has a plus and this has a minus. Now, the only other thing I would memorize here about multiplying binomials, and this is something you probably already do know, is that if you have x plus y times x minus y, this is of course x squared minus y squared. This is a difference of perfect squares, so you factor it as x plus y, x minus y. This is something you've dealt with before. Like, for example, if I said factor x squared minus 4. All right, so actually getting back into the problem here, of course, I'm just trying to give you as many tidbits as possible for the SAT while I'm doing these problems. We know here that after we plugged in that value for a, whatever that was, we ended up with 5x squared plus 30x plus 42. And so, since this guy is f of x plus a, this guy is f of x plus a, we're going to set them equal to each other, and we'll find out what that value of a is. So we'll get 5x squared plus 10ax plus 5a squared minus 3 is equal to 5x squared plus 30x plus 42. So first off, if you get this far, you've essentially done everything you need to do. Algebra-wise, what you could do here is you could plug in your answers from here if you get confused, and just plug those in for A and see which one makes this guy equal to 5x squared plus 30x plus 42. And that's completely fine. You can do that. But a lot of people struggle when they get here anyway. So let's talk about how to do that. How do you actually, because usually when you get to a point like this where you have two quadratics equal to each other or just something like that, you're trying to solve for x. Here we're trying to solve for a. So how does that even work? Well, again, we know that this thing needs to be a 5x squared plus 30x plus 42. That means that since this thing has a 5x squared, this thing needs to have a 5x squared, and it does. Since this thing is a 30x, this guy needs to have a 30x in it. And the only piece with an x is this second term here. So we know that 10a needs to be equal to 30. And so if 10a is equal to 30, then you can probably tell that a would have to be 3. 10 times 3 is 30. Now similarly, 42 would need to equal the pieces without the x, the 5a squared minus 3. Now when you solve that, that's going to be a lot nastier. You'll actually get plus or minus 3. And so you might be wondering, well, is the answer -3 or +3? Well, this guy can only be a +3. So we know that we can't have a -3. It won't work for this guy, for the x pieces. So I'm not going to get into that here. You can check that if you want. But we've already done enough to have solved the problem. So we're good. And we get that a is equal to 3. That is choice answer C. Now moving on here to problem 3, this is a calculator problem, and you're going to need it for this problem. This is quite the doozy. And so we have two triangles here. What that makes me think of when I see two triangles is I immediately think this is going to be some kind of similar triangles problem, and most likely it will be. So what I'm going to do is I'm going to orient these triangles so they look exactly the same. So I'm going to, since the right angle is in the bottom right here, I'm going to rotate this triangle. And I'm going to rotate this guy like this so that it looks like this. Okay, let's get that straightened up. There we go. So I'm going to make this DFE. And I know this is 7. So now these guys, it's going to be easier to do a similar triangles problem when you're already looking at it like that. And this is B, and that's why I've done that. So it says in the figure above, if sine of A is equal to cosine of B, which of the following is closest to the length of segment DF, this guy right here? So first off, what does it mean if sine of A is equal to cosine of B? That's probably the thing that's confusing you the most right now with this entire problem. So let's talk about that. If sine of A is equal to cosine of B, just think about some angles that could make that happen. Well, for instance, we could have sine of 0, that's 0. Cosine of what is 0? Well, we could have cosine of 90. Sine of 30 is 1/2. Cosine of 60 is 1/2. Sine of 90 is 1. Cosine of 0 is 1. So these guys are equal. Notice that in any of these cases, there's something interesting that happens. These two angles had to be 90. It happens the same thing as in this one too, and in these guys. Any time that sine of A is equal to cosine of B, that means that A plus B is equal to 90. So that's something important to memorize about trig because that could happen on the SAT. And generally, I either see that on every single SAT or what I'll see, and this is a little bit more common, is I will see that they'll test you to see if you know that sine of x is equal to cosine of 90 minus x. This is something you should know. And also that cosine of x is equal to sine of 90 minus x. These are two important things you need to know, along with if this is true, then that means that a plus b is equal to 90. And that sort of goes along with this entire thing as well. So that's the pieces of knowledge you need to get out of here. Now, how do we know, how do we use that a plus b is 90 with an example with triangles? Well, we know that all angles in a triangle need to add up to be 180, right? The right angle takes away 90 of that. So we have 90 degrees left to split between angle A and whatever angle is over here. Well, we do have two angles that add to be 90. We have A and B. They add to be 90. So if this angle right here is A, that means this angle is B. So I can write that in. This is B. And since we know this angle is B, and this is a right angle, that means that we have 90 degrees to split here. We know this angle is A. All right? So now we see that all the angles in these triangles are exactly the same. That means that these two triangles are similar. Okay, that's the AAA thing that you learned in geometry. If you have an AAA, all angles are the same, then the two triangles are similar, and that means something very important. That means that I can, let's say I want to find side EF, and we're going to do that because we can't actually find DF immediately. But what similar triangles means is that the ratio between corresponding sides, ratio meaning the ratio here is 5/7. This ratio is going to be equal to the ratio between any other pair of corresponding sides. So another pair of corresponding sides is 8 and x. This is going to allow me to find x, and then I can just find df using the Pythagorean theorem. So let's find x here. Oops. Boop, boop, boop. Boop, boop, boop. Boop. So you can do this using cross multiplication. 5x is equal to 56, and then dividing by 5 on both sides. You can put that into your calculator. This is a calculator problem. Or you can do this mentally. I challenge you to do it mentally because it's fun. And that's probably not true. If you want to do this mentally, you could write this as 56/5 is equal to 55/5 plus 1/5. And do that in your head. And 55/5, 55 divided by 5 is 11. And this guy is 0.2. So this is 11.2. That's how I did it in my head. But, yeah, you don't have to do that. Let's just move on. So now we know that this x right here is 11.2. And so we can find the value of df here. And we'll call that y. So we'll use the Pythagorean theorem here. 11.2 is the hypotenuse. So 11.2 squared is equal to, this is 7 squared plus y squared. So we can put that in our calculator here. I'll just subtract 7 squared on both sides and show you exactly what to plug in your calculator. If you subtract 7 squared on both sides, we're going to get 11.2 squared minus 7 squared is equal to y squared. And then square rooting on both sides, we'd get that y is equal to the square root of 11.2 squared minus 7 squared. So put that in your calculator and you should get the value for df. And that value ends up being 8.7. And that's choice B. So that problem was awful. that does take a little bit of time. Once you know, though, that sine of A is equal to cosine of B, you understand what that means. You understand these other little trig properties that they like to kind of throw in there on the SAT. And you understand similar triangles. Like this problem attacked both of those things. If you know both of those, that will really help for the SAT, because I know so many people get tripped up with that trig thing that I showed you with this stuff. and the sine of A equals cosine of B, meaning the A plus B is 90. So many people get tripped up there. And also so many people get tripped up with similar triangles because a lot of people take this test when they're in like algebra 2. And by that time, it's been a while since they've done all the similar triangle stuff from geometry, and maybe they didn't fully understand it there, so it just gets annoying. But yeah. Let's move on to problem 4 here. And problem 4 is a quadratic formula problem. And it's not a calculator problem, so you can't graph this. Now, how do I immediately know that it's a quadratic formula problem? Because first off, I see that I have a quadratic, and I see that I have radicals in my answers, and that means there's no way that I'm going to be able to factor this. And generally, you will get some like easier quadratics on the SAT. This is still an SAT problem, but like sometimes you'll get much easier quadratics like x squared, let's say minus 2x plus 3. With this quadratic, let's say that your answers for your values of x, they all contain some radicals in them. You know you're not going to be able to factor this outright, and so you know to immediately jump to the quadratic formula. And so that is essentially what I'm talking about here. It's just that we have much grosser numbers that we're dealing with. So let's actually go out and do this now. So we need to get this thing equal to 0. So what I'm going to do is I'm going to add that q over 3x on both sides. So just showing that full step out here. I'm going to add that q over 3x. So that goes away. Then I get an x squared plus q over 3x plus 1/2 r is equal to 0. This is my constant piece. That is my c. And I think it's good to just even go through and talk about what a, b, and c are here. But first, I don't like these fractions. I don't like dealing with that. So what I'm going to do is I'm going to multiply each side by 6. The reason why I'm multiplying by 6 is because I know it'll get rid of both the 3 and the 2 in the denominators. I'll end up with a 6x squared plus a 2qx. The 6 will become a 2 and this will become a 1. And then I'll get a 3r. And that's equal to 0. So now from here, it's a little bit nicer to deal with. I know that my a is 6. My b is 2q. It's everything but the x. And my c is 3r. Make sure you include the r. Our independent variable here is x. So everything that's not an x goes, like the q and the r. So now let's actually use the quadratic formula that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And just going through and doing that here, we get that x is equal to a negative 2q plus or minus the square root of a 2q squared, which is 4q squared. Right, don't make the mistake, this is not 2q squared. This b squared is going to be a 2q squared, which is 4q squared. So that's 4q squared, and then we have minus 4ac. So we have 4, a is 6, c is 3r. That's all under the radical, and then we have a 2a, which is 2 times 6. So now, let's drag this over, and let's simplify a little bit. This is negative 2q plus or minus the square root of a 4q squared minus, this is a 24 times 3r would be negative 72r. 24 times 3 is 72. And this is a 12, we'll put that in the denominator. So what we can do now, look at our answers. They all have the fractions split up. So what I'll do is I'll split up this fraction. I'll write this as x equals a negative 2q over 12 plus or minus the square root I'm just going to copy paste. I'm getting lazy here. This is annoying. And this guy's over 12. And first off, here we can see that this is going to reduce to be a 1. This will be a 6. And so we get a negative q over 6 here. And so looking at our answers here, that means that it's not going to be C or D. Those don't have a negative q over 6. But what that also tells us, here we have a 12 in the denominator. We need a 6 for it to be one of our answer choices and for us to figure out whether the answer is A or B. So we got to do that. And we'll see what we get under the radical. Whatever we get under there is going to tell us what our answer is. So let's do that. Here we get a negative q over 6 plus or minus. And how do we simplify this? How do we get a 6 in the denominator? Well, you can look at the actual radicals for clues, but you can see that the q squared is by itself in either one of these. So that means we need to factor out a 4. And so we can write this as the square root of, let's do this first, 4 times q squared minus, what is 72 divided by 4? Absolutely right, it's 18. And then you get, this is over 12. And from here, you can write that as x equals a negative q over 6 plus or minus. You can split this radical up at this point. If you don't already know, that you can just bring this out and it's a 2. You can write this as the square root of 4 times the square root of q squared minus 18r. The 18r probably already gives away what the answer is. If you look at your answer choices, you can already see here that we're going to end up with this being choice A. But I'll keep going here just for the sake of it. This is over 12. And this right here is a 2. So that means that this reduces to be a 1, this reduces to be a 6. And in the end, you get negative q over 6 plus or minus the square root of q squared minus 18r over 6. Okay, and there you go. So that's a lot of work. And there is a way to speed this up, and somebody actually mentioned this to me in a TikTok comment, which I was really happy about. And I like this way. So instead of multiplying by 6 on both sides, what you could have done is you could multiply by 3 on both sides. But how would you know to multiply by 3? Because when you have all these disgusting constants floating around, what you can do is you can realize that b squared is going to be the grossest thing. That gave us a 4q squared here, and that was a little bit messy to deal with when all of our answers just had a regular q squared in it. And so if we just eliminated the fraction and made the b term the simplest we possibly could, so if we made it a qx instead of a 2qx, then we would have immediately got q squared instead of 4q squared. We wouldn't have had to do this factoring out thing, and we would have saved ourselves a couple steps. Of course, then we would have had to deal with a couple, fractions here. Like this would have been a 3/2 r. So it might have gotten a little bit messy, but it would have been a lot nicer than what we did. So there's a little bit of a hack, but you probably weren't going to see that, I think, looking at this problem, and I didn't when I looked at this. So that's why I was teaching this way. And if you want to go through, try multiplying by 3 on both sides instead of 6, and you'll see how it gets a little bit nicer, but not incredibly nicer. Let's do this last problem here for this first set of 5. And this one is much nicer than problem 4 or problem 3. It says, which of the following complex numbers is equivalent to 5 minus 3i over 6 plus 4i? And the reason why I put this on a harder problem video is not because this process is that hard, but a lot of people have trouble dividing complex numbers because, first off, a lot of people haven't even learned how to do that yet. And also, I think like when you're talking about complex numbers, this is probably the most difficult thing that you learn when you are talking initially about complex numbers, because multiplying them and like adding them and subtracting them, that's not too hard. Dividing them loses a lot of people. So that's why I wanted to actually do a problem with dividing complex numbers. So how do you divide complex numbers? Well, what you do is you multiply top and bottom by the conjugate of the denominator. And what the heck did I just say? Well, the reason, actually, before I even talk about that, when you're dividing two complex numbers, what you want is you want something in a plus bi form. That's what you're trying to get. And you can't have something like that if you get imaginary numbers in the denominator. That just won't happen. You can't have imaginaries in the denominator, or else this thing won't be in that form. And so the goal here is to get all the imaginaries out of the denominator. And so what we do is we want to multiply by the conjugate, and I'll talk about what that is, of the denominator, because multiplying by the conjugate will cancel out the imaginary numbers. Now, what does the conjugate mean? Well, the conjugate of the denominator here is going to be 6 minus 4i. What we do is, and a lot of people, they'll take this imaginary piece and they'll just they'll switch the sign. So if it's a positive, they'll make it a negative. If it's a negative, they'll make it a positive. And so that's how a lot of people like to do the conjugate. Now, I will say this, I don't want to confuse you here, but I feel like I have to say this. You don't have to do a 6 minus 4i and switch the sign of the imaginary piece. You could change the sign of the real piece, so you could make it negative 6 plus 4i. And you could change this sign instead of changing the plus 4i. But you'll get the same result. I don't want to confuse you though. Just switch the sign of the imaginary part and multiply that on top and bottom. When you do that, you'll see how in the denominator, the imaginary parts cancel off. Here we're going to get a 6 times 6 is 36. We have a 6 times negative 4i is negative 24i. A plus 4i times 6 is 24i. And then a 4i times negative 4i is negative 16i squared. We'll do the numerator here. We have a 5 times 6 is 30. 5 times negative 4i is negative 20i. Negative 3i times 6 is a negative 18i. And a negative 3i times negative 4i is a positive 12i squared. Now the only thing to remember here is that I squared is negative 1. How do you know that? Well, this whole I thing that I've been talking about is equal to the square root of negative 1. And so if you have I squared, that is equal to the square root of negative 1 times the square root of negative 1. And that's equal to negative 1. The radicals go away when you're multiplying by two of the same radicals. Right, just as when you take, for instance, you take 3, or let's say you take rad 3 and you square it, you get just the 3, the square root and the square cancel off. When you take I and you square it, which is I is the square root of negative 1, and we're squaring that, the square again cancels off with the square root, and you're left with negative 1, just a thing that was under the radical. That's why when you multiply two of these radicals that are the same, you just get the number that was inside the radical. So that's why that happens. And so I squared is negative 1, and that's something you should remember. If you know that, you can solve this problem pretty quickly from here. This is going to end up equaling a 30 minus 12. How do I know it's a minus 12? Because this is a I squared, that's a negative 1. So it's 12 times negative 1, and that's negative 12. 30 minus 12 is 18. And then we have a minus 20i minus 18i. That's going to be a minus 38i. And that is all over. You see that these guys go away. That was the whole point of multiplying by these conjugates here. And we get a 36 minus 16 times negative 1. So this is a plus 16. So it's a 36 plus 16, that's 52. So you see now we have no imaginaries left in that denominator. And so that means we can put this into a plus bi form, and so we can consider this divided. So you can see here in all our answers, the fraction is split up. So we'll write this as 18 over 52 minus a 38i over 52. And you can probably see here we can simplify all this by just dividing everything by 2. So we can get a 9 over 26 minus this looks like it'll be a 19 over 26, 19i over 26. And that will give us our answer of choice C. And so while this problem isn't nearly as long as like problems 3 or 4, it still is a problem that a lot of students end up just having trouble with and not really understanding how to do. So that's why I definitely wanted to cover it in this video. And so that's our first 5 problems. So, take a breather, take a little bit of a break, and, you can come back to this video. And if you guys are enjoying this video so far, I mean, maybe not enjoying, but if it's helping you a lot and you feel like you're taking a lot from it, then you're in luck, because I want to tell you guys a little bit about my full SAT course. So while this video is a great place to start studying for the SAT, in my full SAT course, I go over all the topics you need to know for the SAT, and we also do plenty of practice problems for each topic, easy, medium, hard difficulty, so you really get feeling confident with each topic. I also have video explanations for every single practice problem in the course, as well as tests at the end of each section, so you can track your progress. And so if you're interested in that, be sure to click the link in the description down below. Now let's get into the next 5 problems for this video. So beginning our next set of 5, I do want to point out that these problems are not going to take as long as the first 5 did, because those were just really long problems in general. I probably should have started with some shorter problems first, but this one will be better. So this one is a problem that a lot of people have struggled with. A lot of people ask me about this saline problem. And so here, this problem says, how many liters of a 25% saline solution must be added to 3 liters of a 10% saline solution to obtain a 15% saline solution? And a lot of people, first off, this problem is hard because people are trying to convert words to math. But a lot of people get stuck and they try to think of the chemistry behind what's going on here. And that is not at all where your mind should be when you're looking at this problem. This is just a quick percent problem. And I'll show you why. This problem starts off with how many liters. Okay, we don't know how many liters. That's why the question's asking us for that. So we have X liters. That's how many. And we need to figure out what X is. Now, it says of, so we know we're multiplying, 25%. 25% is 0.25. And why is of multiplication? Well, where you see this a lot is what is 30% of 60? They'll say a lot of stuff like that. And in that case, what you do is you convert the percent to a decimal. Just, take the decimal place here and move it twice over. And you multiply that times the number that comes after the of, which is 60. We're doing the exact same thing here. So we get that first little bit. And so now this piece is done. But then it says, must be added to 3 liters. So we're adding 3 liters of a 10% saline solution to obtain a 15% saline solution. Now, what do we do here? Well, we're not adding anymore. We're essentially getting a finished product over here. This is a whole different thing. This would be on the right side of the equation. If you think about the chemistry, I guess it might help a little bit, because you have your ingredients on the left-hand side and your product is on the right-hand side of the equation. So it's kind of like the same thing here. So we're trying to get a 15% saline solution. But there's an issue here. Do you see the issue? What's missing? What about the number of liters of the 15% saline solution? How many liters do we want? And looking at this equation, you should be able to tell me how many liters we have. We're not going to magically gain or lose more solution, right? How many ever liters we start with is how many liters we're going to finish with. And so, how many liters did we start with? Well, 3 plus X. So that's going to be the number of liters that we finish with. So over here, I'm going to write a 3 plus X. Or actually, I'm just going to write an X plus 3 instead of 3 plus X. I don't know why, but it was kind of bothering me writing it like 3 plus X. And also, over here, the X comes before the 3. So it's neater this way, okay? All right, so now we just solve for X, and this is quick. We have 0.25X plus 0.3. That's what this will end up being. And I'll just make that 0.30. And now we just distribute that x. Now we just distribute that 0.15 through. So we have x times 0.15. I shouldn't say 0.15. A lot of people get mad when people do that. So I'm gonna just not do that. Like, I saw a TikTok once, and there was this one guy that was just shaming everybody that says 0.15. And I was like, wow, you care that much about decimals. But that is all to say that now over on the right-hand side, we get 0.15x plus the 3 times the 0.15 is 0.45. Right, just 3 times 15. And so now, let's subtract the 0.15x on both sides, just to get all our x's over to the left-hand side, and then I'll get everything without the x to the right-hand side. So on the left-hand side, I'm left with a 0.10x, and on the right-hand side, I'm left with a 0.15. And so now I can just divide by a 0.1 on both sides. And so x is equal to this ratio right here. And you might already be able to see that this is going to be 3 halves. If you don't see that, just look at the ratio between 15 and 10. It's the same thing. Let's multiply this by 100 over 100. This is 15 over 10. And then you can divide it by 5 over 5 to get 3 over 2. That would probably be the nice easy way of seeing that, if you, or the long way of doing it if you don't see this right away. But yeah, you could just see that, oh, you have 15 over 10, that ratio, it's 3 halves. And that's your answer here. So moving on to the next problem here, we have if 3x minus y is 12, what's the value of 8 to the x over 2 to the y? Now, this is another problem that a lot of you guys have sent me on my Instagram, which is just Ludus12. I also have that in the description, but you can DM me there if you just have any questions that you want me to make a video on. And yeah, but a lot of people have just thought that the answer here was choice D, and that's not quite it. So let's actually talk about how to do this problem here. First off, this is very different than like a system of equations. So a lot of you were wondering, well, okay, if you have like x plus 3 equals y and like, 2x plus 2y equals 5, this is a system of equations, and you need 2 equations to be able to solve for x and solve for y. Now, this is not the same kind of thing. Here we have one equation and we have an expression. This thing does not have an equal sign, it is an expression. So there's different rules at play here, and what we can try to do is simplify this expression to a point where we can use this equation or just do something like that. There's ways to simplify what we're given here. And just what I immediately see when I'm looking at this is I have 8 to the x, which I can write as, instead of it being an 8 to the x, I'll write it as I gotta give a little more space there. I'll write the 8 as a 2 to the 3rd power. Because what that does is it gives it the same base as the denominator, and that means I can actually do some math here. I can use my exponent rules and I can get a nice expression that has 2 as the base. So what I can do from here, again, I have the 2 powers up here. When I have a power to a power, I multiply them. So I get a 2 to the 3x over 2 to the y. And when I have the same base on top and bottom, I subtract the powers. When 2 things are being divided, they have the same base, we subtract the exponents. So this is 2 to the 3x minus y. And this 3x minus y is important. And the reason why it's important is because, well, we were given in the problem what 3x minus y is. It said in the problem that 3x minus y is 12. And so I know that 8 to the x over 2 to the y is 2 to the 12th power. I just substitute that 12 in for the 3x minus y. So that is the answer here. Oops. And that's choice A. So that's it for that problem. Let's move on to the next problem. And this is the type of problem that I feel like people would look at on the SAT and they would just go, nope, no. Next, let's go to the next problem because this one looks ridiculous. I agree. It looks ridiculous to an extent, but it's not as hard as you might think. It's actually kind of like common sense in a way. And I don't mean to say that to say, oh, if you get this wrong, then you're just dumb. That's not it. I'm just saying that this problem is a lot easier than you might think it is. So that's why I wanted to include it here, because a lot of people, they look at these problems that look a little grosser on the SAT, and they're just like, no, I'm not going to do that one. But it doesn't end up being that hard. So this problem says the figure on the left above shows a wheel with a mark on its rim. The wheel is rolling on the ground at a constant rate. It's always good to underline things like, when it says a constant rate, it means it's moving at a constant speed, right? It's moving with constant velocity. It says along a level straight path from a starting point to an ending point. Cool. The graph of y equals d of t on the right could represent which of the following as a function of time from when the wheel began to roll. So what is this last sentence saying? It's saying, what does this graph mean? And let's just try to use process of elimination here, because it might be hard at first to see what this graph actually represents. So first off, A, the speed at which the ball is rolling, at which the wheel is rolling. Well, no, the wheel is rolling at a constant rate. We circled that in the problem, so it's definitely not that. It's not like the speed is not doing this. And then the distance of the wheel from its starting point. So this is the starting point here. And this distance is not going to zero. It's not coming back to zero. This graph wouldn't make sense. It's not like starting away from where it started. Like imagine this value being something like 3, and this is something like 0. It's not starting away from where it started from and then coming back to where it started from. That makes no sense. Like what I said literally just doesn't make any sense. So it's definitely not B. The distance of the mark on the rim from the center of the wheel. Well, no, this mark is not changing. That distance is not changing. This guy is just going around the circumference here, and it's enjoying its time. It's not C. That's just constant. It's constant, so it would look like this. It's not gonna like wave back and forth. So that leaves D, and D is the answer here. But let's actually read it and make sure. Now, first off, how is this distance changing from the mark to the ground? Well, as the ball would roll, this mark is going to go down around here, around this circle, and then go back up. So this distance from the mark to the ground is getting smaller, and then it's getting bigger again. Smaller and then bigger again. And so you have these oscillations back and forth. And that should clue you into the fact that, well, this graph is oscillating. It's going back and forth. And so, of course, that's going to be the answer here. It's going back and forth throughout time. So that is the answer here. It's choice D. So now, problem 9. This is another problem that I think a lot of people just would read. They wouldn't really get what's going on here, and they would just give up. So here's the problem. We'll do it slow. A psychologist set up an experiment to study the tendency of a person to select the first item when presented with a series of items. In the experiment, we have 300 people. Okay, cool, 300 people. Were presented with a set of 5 pictures arranged in a random order. Each person was asked to choose the most appealing picture. Of the first 150 participants, 36 chose the first picture in the set. So we have 300 to start off with. There's choosing between 5 pictures, cool, whatever. Of the first 150, we know that 36 chose the first picture. And you might choose to represent this differently. That's just this is me doing scratch work here. Now, the next sentence says, among the remaining 150 participants, so another 150, the other one, P people chose the first picture in the set. And these aren't minuses, by the way. I don't mean to do that. Like, I'll write colons. How about that? Of the first 150, 36 chose the first picture in the set. Of the second 150 P people chose the first picture in the set. And so if it says if more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values of P? Now, you might be sitting there going, what the heck did that last sentence say again? And that's kind of what I did at first when I was reading this. I was like, man, this is a lot of information, because it is. And, I'm really just trying to piece this apart as I go, but, maybe I got to account for the fact there was 5 pictures, or maybe I got to do other stuff. I don't know. But what I would say is, all this seems to be about, numbers of people. And so I don't think I would really care about how many pictures there were. So I'm not really including that data. I'm really more concerned about this. And if you look at this last sentence, it says, if more than 20% of all participants, so we're saying more than 20% of what? I want to make that look a little nicer. There we go. 20% of all participants. So there's 300 participants. Chose the first picture in the set. Which of the following inequalities best describes the values of P? So what is greater than 0.2 times 300? Well, we're saying more than 20% of all participants chose the first picture. So how many people chose the first picture? That's what's going to go over on the left. Well, can you tell me? 36 people chose it in the first 150. P people chose in the second 150. If we combine those, we get the total number of people that chose the first picture. And so, we're solving for P here, or at least that's what the question kind of seems like. You can subtract 36 on both sides, but this is why it's kind of good to be watching your answer choices as you go through the problem, because you don't actually have to solve for P, and that's a little weird. Like the problems, it doesn't require you to solve all the way for P, but if you look at here, you look at the problem, it already gives you that exactly what we have here. So you don't need to solve all the way for P. That's fine. No big deal. We've already solved the problem. But it is tough to organize the information sometimes. And sometimes these things like, hey, we had 5 pictures. We didn't factor that in at all. So how do we know not to factor that in? Well, it's kind of the outlier. It's not like the other pieces of information. All the other information that we've been talking about is like people. We've been talking about numbers of people. And so why would we talk about the number of pictures we were choosing from? That's what really did it for me. So yeah, that's the 9th problem. Now let's get into the last problem for this set of 5. That problem being, the mean score of 8 players in a basketball game was 14.5 points. So we had 8 players. That 8 looked horrible. Try again. 14.5 points. Now, if the highest individual score gets removed, the mean score of the remaining 7 players is 12 points. What's the highest score? So I get sent this problem a lot, actually. And I think the reason why a lot of people have trouble with this is because they're trying to figure out what's the relationship between the highest score and the mean. Obviously, you would say that if you took away the highest score or the highest number in an average, that average is going to go down. Right? That would make sense. But why? How does that actually relate? Well, think about what a mean actually is. The mean is in this case, is the sum of all scores. Jeez, can't even write. Over the number of players. That's what the mean is here. It's the sum over the number of things that you just summed up. And so, what does that mean for us here? What does that mean for us here? That was lame. Well, our mean for the 8 players was 14.5 points. So we had 8 players, and that will tell us the sum of the score for all 8 players, which might help us. I'll call that T sub 8, that variable, for the total number of points scored by 8 players. We also know that 12 points is the mean scored for 7 players. That's the total of the bottom 7 players. So I'll call that T sub 7. Now, how do I find the highest score? Well, if I subtract the total that of all 8 players, and I just take out the bottom 7 players, the only thing that I'm left with is the amount that the top player scored. That's the only thing that separates these two numbers. And so what I got to do is calculate the total score for all 8 players and then subtract the total score for the bottom 7 players. And we can do that. Let's just quickly calculate those things. What I can do here, and I'll just move these guys over. What I'll do is I'm going to take these, just got to have better paper organization here. There we go. So I'm going to write this as T sub 8 is equal to, let's multiply 8 on both sides. It's going to be 14.5 times 8. This is a calculator problem, so you can put that in your calculator. I'll probably do that mentally. This is the same thing as 29 times 4, which would be 116, I think. Yeah. And then you can do T sub 7, which is going to be the 12 times 7. How do I do that mentally? So 12 times, if you do like the 12 times tables, I know this doesn't matter because you could just put it in your calculator, but I need to just share this information. I don't know why, so please forgive me. But like, if you're doing the 12 times tables, then like all of these numbers, like the first 4, they have the same starting number as like the number that you're multiplying by. But once you get past the first 4, all these numbers, you have to go like 1 greater to get these numbers. And so that's how I know that 12 times 7 starts with an 8. And then it just makes sense that the last number is a 4 because I vaguely know what these are supposed to be. That's how I do this, okay? Leave me alone. Thank you. Bye. So this is 84. And so that's 116 minus 84, and if you do that in your head, which you won't, you'll put it in your calculator, that's 32. Cool. That's it for the 10th problem. I just want to get away from this problem right now. All right, that's choice C. So that does it for, let me X out of that. That does it for the first 10 problems for this video, our next set of 5. So now take a breather, take a break, just something to give yourself a rest, and then come back. We'll get our next 5 problems done. So starting our next set of 5 problems here, we have a problem about circles. This problem says that the equation above defines a circle in the xy plane. What are the coordinates of the center of the circle? Now, just for this problem right here, a lot of people get confused when trying to find the center and the radius of a circle. So I'm going to go through and just find the center and the radius of this circle, and then I'll show you a nice little hack that you can use to just if you need to find the center and nothing else. So we'll talk about both those things. First, I'll do it all out because doing it all out involves having to complete the square twice, and so we'll talk a little bit about that. Now, how do you start off? By getting this thing into the standard form for a circle. Well, the standard form for a circle, okay, so the equation of circle is the following. It's x minus h squared plus y minus k squared equal to r squared. A lot of people mess up right here. They think that this is just the radius, but no, what goes over here in the standard form of a circle is the radius squared. So when you get this guy, you need to square root it to get your radius. And the center here is h comma k. Notice that you have minus signs here and here, and what that means is that whatever is here, like let's say you get a x plus 10 squared, that means that your h here is negative 10. So you always got to flip the sign. And we'll talk about that a little bit in a second. But that's the equation of a circle. And we want to get this guy into this form. so we can identify what the center is, what the h comma k is. And so let's go and do that. We need to complete the square to get this thing into this form and then this guy into this form. So we'll start with the x's here. And to complete the square with the x's, with the x squared plus 20x, what we're going to do, I have a whole video on completing the square that you can check out if you're I don't know, just not really sure how completing the square stuff works, or just you're really shaky on that topic in general. But here's the basics. There's a three-step process I use to completing the square. The first step, I draw this thing, and then I divide the b term, essentially, the coefficient on the x, by 2, and that gives me 10 here. That's step 1. Then I square this thing, which is 100, and I subtract it. And then the third step, which I don't need to do here, but generally when you're factoring a quadratic, there'll be an extra piece here, and you bring that down as the third step. But here we don't have that. We just have an x squared plus 20x, and that's it. So this step wouldn't need to be done. So that's the x pieces, and really, that's it. So now let's do the y's. Now, for the y's, we're going to write this thing, and then step 1, divide this piece by 2 and stick it here. Then square this guy and subtract it. And that's it. Oops. And then that's equal to negative 20. Awesome. So now we almost have this in the standard form of a circle, except for this negative 10 and negative 64 are still on that left-hand side, so we want to get that to the right-hand side. We can do that pretty quickly. Just add 100 and add 64 on both sides. Doing that, we get x plus 10 squared plus y plus 8 squared is equal to 164 minus 20 is 144. And from there, we can actually talk about what the center is and what the radius is of this circle. The center would be negative 10, comma, negative 8. Remember, we flipped the signs for both of these. And I think it's always good to talk about why we flip the signs, because a lot of people are they're confused on why. It's different if you plug into x plus h versus x minus h. Here in the standard form of a circle, we have x minus h. And so let's say that we ended up with an x plus 10, which is what we had here. We have an x plus 10. If the x plus h was the standard form of a circle, let's say that this was the standard, then of course h is 10. That makes sense, because if you plug in a 10 here, you get x plus 10. So you wouldn't flip the sign. But let's say that which is the actual standard form of a circle, you have an x minus h. Now, what value of h do you have to plug in to get a plus 10? Well, you'd have to plug in a negative 10, right? Take that h and plug in a negative 10. Now, you get the x plus 10 that you have up here. That's why you have to flip the sign, because this minus changes things. It's not a plus, and that means it does different things. It always flips the sign. So you essentially flip it back. If you see an x plus 10, you make it a minus 10, just like we did here. So that's the center of the circle. And then the radius here, can you tell me? It's not 144, please don't say that. It's 12. You have to square root this thing. Remember that this piece, the 144, is the radius squared. If you want the radius, you need to actually square root both sides. It helps if you set r squared equal to whatever you get over here, and then you square root both sides. Okay, cool. So of course we can already see here that the answer is choice B. But I did say that I wanted to show you a little bit of like a hack, essentially. A way that you can do this even faster when you're just talking about the center of the circle. And this actually is a hack for just regularly completing the square with a parabola. With a parabola, let's say you have, something like this. Y equals x squared plus 4x plus 4. Now, if you wanted to find the x coordinate of the vertex, so you have your parabola somewhere over here. Let's say that you want to find the x coordinate of your vertex. So you want to find the h. All you have to do that is use this formula, negative b over 2a. And why is that? Well, it actually comes from this completing the square process. Remember how we took that b term and we divided it by 2? That's where the b over 2 comes from. The negative comes from the fact that since we get a plus 10, we have to make it a negative 10. That's where the negative comes in. And then the a comes from the fact that, like, let's say we had a 4x squared here. We would need to get that x squared by itself, so we need to factor out that 4. And that's the a. So the a is from factoring out whatever goes here. But that's a little much. We don't really need to care that much about it. I mean, it's good to know, but really you just need to use this formula. And this would tell you what your x coordinate is of this parabola, like what the x coordinate of the vertex is. So here that would be negative 4, because we have a 4 here, over 2 times a is just a 1. So you get negative 4 over 2, and that's negative 2. So that would be the x coordinate of the vertex of this parabola. And that's all for that. But how do we apply that with a circle? Well, it's the exact same thing. What you could do is negative b over 2a for both the x's and the y's here. So take this x squared plus 20x plus y squared plus 16y equals negative 20. And for the x piece, do negative b over 2a. That's going to be a negative 20. This is the b. Over 2 times a is the coefficient on the x squared, and that's a 1. So that's a negative 20 divided by 2, and that's a negative 10. That's the exact same thing we got up here, but it's a lot quicker to do it this way. Then, doing it with the y's, we just do the b and the a for the y piece. The b for the y piece is the coefficient on y. That's 16. So we have a negative 16 because, of course, remember, it's negative. Then we do 2 times the coefficient on y squared, which is 1, and that's negative 8. And there you go. You get the y, the y coordinate of the center. And so that's really quick, and that's actually the fastest way to really look at this. You can do it rather quickly. But it is good to see this entire thing out because let's say you're asked for the radius, you need to actually go through and calculate that. That's going to take a little bit. So that's a full scope of how to do these circle equation problems. So next problem here. This one is a little bit tricky because you need to know this geometry theorem that honestly I don't remember learning in geometry. I'm sure we learned it, I think, but I don't remember it at all. And so I actually had to review it when, looking at the SAT. So here it is. This problem says that point P is the center of the circle in the figure above, and it asks what the value of x is. Now, we're looking for this angle, and all we're given is that these two angles are 20 degrees. So what do we do? Well, notice that this little, I don't know, whatever this guy is here, this quadrilateral, it's a quadrilateral. It's got 4 sides, a side here, 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 and here. Essentially that little arrowhead, I guess we can call it. Now, that means that all the interior angles have to add to be 360, and that's kind of what I was thinking here. Because if that's true, then we know that 20 plus 20, because those are two interior angles. We know that this angle is 360 minus x. And why do we know that? Well, because with a line, we know that, of course, these two angles add to be 180. But with a point, think about it like a circle surrounding it. With a circle, those interior angles add to be 360. But it makes more sense if you have a point and you surround it with a circle, because you can divide it into essentially a circle, and all of these angles around it add to be 360. So this, all the angles around this add to be 360, and that means that if you want the angle measure of this piece, it's 360, the entire thing, minus the x. So we get that part. But what's the angle here? Well, to talk about that, you need to know the inscribed angle theorem. Now, this theorem says a couple things. First off, and not really that this pertains to this problem because it doesn't, but it is something you need to know, there are two different kinds of angles here. There are central angles in a circle, which are angles that go to the center, and there are inscribed angles. And those are angles that will go all the way to the edge. They're made up of two chords, whereas central angles are made up of two radii. Now, the actual thing that we're going to talk about first is just the inscribed angles. And inscribed angles have this special property where if they start and end at the same points as another inscribed angle, we know that these two inscribed angles will have the same angle measure. So let's say angles ABC and angles ADC will have the same angle measure because they are both inscribed angles that start and terminate at the same point. And that's interesting to know. That's something that is asked too on the SAT, but this question, we have a central angle and an inscribed angle, and they start and end at the same point. And that is an important relationship to know as well, because with that, drawing another one here, what we now have, here's like the center of the circle, we have something that looks like this. We know that this piece is x, and we're asking what this piece is. What the inscribed angle theorem says is if this central angle is x, this inscribed angle that starts and ends at the same point, it just goes to the end of the circle, or just, goes, it terminates at some place along the edge of the circle, it'll be x over 2. It'll be half the angle of the central angle. And so that's important. That means that this angle right here is x over 2. It's half of the central angle. And so we write this as x over 2. And of course, all these angles added up is going to be 360. Now from here, it's just solving for x. That's really what it ends up being. We can do that pretty quick. This is going to be a 400 because we have a 20 plus 20 plus 360 is 400. Then we have a minus x plus x over 2. That is going to be a minus x over 2. You can use common denominators. You can write the negative x as a negative 2x over 2. Just multiply by 2 over 2. And you can add that to x over 2, getting you negative x over 2. That's how I got this. And then this is going to equal 360. Let's subtract 400 on both sides, giving us negative x over 2 is equal to a negative 40. And let's multiply by both sides with a negative 2. And that'll cancel out the negative 2's. So we get x is equal to 80. And that is the measure of that central angle right here. So that's all you got to know, is that if you have your central angle here and you have an inscribed angle that starts and ends at the same points, then it's going to have half of the angle measure. That's all you got to know. Oops. Bam. Oh, and one other thing before we move on to that problem, actually. The only other angle theorem that you need to know, or the only other circle theorem, is that if you have some chord on a circle, and you go from your center point, you can always draw a perpendicular bisector to this chord. So you can draw a line that will be perpendicular to the line and will cut it in half. So this length is the same as this length. That's the only other thing. And that of course kind of is like, it almost seems like common sense in a way. But yeah. Now this next problem looks disgusting. It probably looks like the most disgusting problem that we've had in this entire video, but it's actually one of the easiest, and I promise you when I say that, that's seriously it. Let's talk about this. First off, looking at this problem, you should almost immediately be able to tell me what we're doing here. We have an equation for m, and then our answers are all equations for p. So what do you think we're doing here? We're probably solving for p and seeing which of our answers is correct. So how do we solve this gigantic thing for p? Well, guys, p's already by itself here. It's already kind of separated from this disgusting fraction. And I'll show you how easy this actually is. I mean, just let the numerator here, this disgusting thing, let this guy be x. We'll say that this thing is equal to x. And we'll let this thing equal y. What we actually have right here is just a more complicated version of m equals x over y times p. That's really all it is. It's just that x and y are really gross expressions. And so, of course, we can substitute back in later, but let's just compact that all down to a single variable, and then we'll substitute back in later. Let's multiply each side by y over x to solve for p. And when we do that, y's go, the x's go, and we're left with p is equal to m times y over x. Or just to be in terms like we have in our answers, the m is just kind of separated out. So we'll write this as y over x times m. Now remember, we said this is y, this is x. And so our disgusting denominator is now in the numerator. Our disgusting numerator is now in the denominator. So these just switch. And that's it. So that's going to be choice B. That's all there is to it. When you see something really disgusting like that, it is nice to just compact it down and just make it as simple as possible for yourself, because they're just trying to really confuse you with a bunch of stuff. I mean, yeah. So moving on to problem 14 here, this one's actually pretty similar to problem 2 in that now you're solving for constants, you're not solving for x. So if you understood problem 2, you understood like the second half of that problem, then this problem right here shouldn't be that much more difficult. So for this problem here, it says if ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b is 8, what are the two possible values for c? So again, we're given that this ax plus 7 times ax plus 2 times bx plus 7 is equal to 15x squared plus cx plus 14. And what the first thing I want to do here is just distribute this out, because then we'll get a quadratic on this side equal to a quadratic on this side, and that's going to be really nice for us just actually doing work with constants. So first, multiplying the ax times the bx, we're going to get ab times x squared. Then let's multiply the 7 times the ax, and that'll give us a 7ax. Multiply the 2 times the bx to get a 2bx. The 2 times the 7 will give us a 14. And then that will be equal to the right-hand side. So now, we have these two quadratics equal to each other. This is where it gets very similar to the second problem that we did. Because if this side has a 14, then this side needs to have a 14, and it does. If this side has a 15x squared, this side needs to have a 15x squared, and that means that AB needs to be 15. And again, why do these sides have to be equal like this? Why does each term, if one side has a 14, the other side has to have a 14? Well, it's because these things are equal, and if these things are equal, then if this thing is a 15x squared plus cx plus 14, this thing needs to also be a 15x squared plus cx plus 14. That's the only way that these guys will be equal. Right? That's the only way they'll be equal for all values of x that you can plug in, if they're exactly the same expression. And so we see here that 15 would need to go here. It needs to replace that AB. And so that means that AB is equal to 15. Now that right there is going to be enough for us to solve for A or B, whatever one we want. We just need to use this fact that A plus B is equal to 8. Because if we use that, then what we have here is a system of equations. And we can solve this system by solving for, let's solve for B in this one. We can do that by subtracting A on both sides. And we get that B is equal to an 8 minus A. So if B is the same thing as 8 minus A, then this B is an 8 minus A. And so we plug that in. We get that A times 8 minus A is equal to 15. And what that'll give us, just multiplying out here, the A times 8 is 8A. The A times the negative A is negative A squared, and that's equal to a 15. So I'd like to have a positive a squared. It's always nice to have that positive x squared, right? I always like seeing that there. So what I'm going to do is I'm going to add the a squared to the other side. And I want to also, just to get everything on one side, I'm going to subtract the 8a to both sides. That way, on the left-hand side, we're left with 0. And on the right-hand side, we're left with an a squared minus 8a plus 15. This is going to become, well, what are two numbers that add to be negative 8 and multiply to be 15? How about negative 3 and negative 5? So this is going to become an a minus 3 and an a minus 5. So here a would be 3 and a could be 5. Cool. So we found a. What does that tell us about b? Well, we could use either equation, to be honest. We could use that. It might even be helpful to use b equals 8 minus a because, well, if b is equal to 8 minus a, if a is 3, then b would be 8 minus 3, which is 5. So if a is 3, b is 5. And if a is 5 here, then you get an 8 minus 5, so b is 3. So those are your two solutions. A could be 3 and b is 5, or you could get a is 5 and b is 3. So great, we have these possible values for a and b, but that's not what the problem's asking for. The problem's asking for the possible values for c. And since we found these possible values for a and b, now we can find the values for c, but the question is how? Where's the relationship? Well, there is one piece of this equation that we haven't examined yet, and that is if this side has a cx, then this side needs to have a cx, and that will come from the two x terms. That means that 7a plus 2b needs to be a c, so these would add up to be a cx. So let's write that equation. 7a plus 2b needs to be c. And This should not be in yellow. Let's make that in white. Nice. We can plug in the two possible scenarios. We could have that A is 3 and B is 5. In which case, I'll write it. Let me write it this way, actually. Just because it's going to be easier to show. In this case, we have 7 times 3 plus 2 times 5. That is a 21 plus a 10, and that is 31. Now we can also have that A is 5 and B is 3. In that case, we have a 35 times, or 35 plus a 6, and that's 41. So the two possible values for C is 31 and 41, and that is choice D. So these problems take a little bit of work, and generally these constant problems, they do mess up a lot of people because I don't think it's really something that you talk about too heavily in your algebra class. I don't remember really talking about this at all. Maybe we did though, I'm sure we did at some point. But it is a complicated topic, and that's why I definitely wanted to have, there's multiple problems that have at least included this somehow. So, yeah. So moving on to problem 15 here. Take a look at this problem and tell me what you think this problem is about. So, we see x feet here. That probably means we're trying to solve for that side. But more importantly, we have two triangles. And whenever you have two triangles in an SAT problem, generally what I'm thinking is, well, this might be a similar triangles problem. Because why else would you have two triangles in a problem? Maybe if you're trying to find different angles here and there, you would have two triangles maybe just in some random diagram. But a lot of the times when you have two triangles, it's a similar triangles problem. So let's actually see if we're right here. This problem says, a summer camp counselor wants to find a length x in feet across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet, respectively. So let's hold up there. Let's actually just label this here. AB is 1,800. EB is 1,400. BD is 700, and CD is 800. Segments AC and DE intersect at B. Okay, so that's AC and DE. So these guys intersect at B. That's cool. That doesn't really give us anything new. We get that. And angle AEB and angle CDB have the same measure. Yeah, they're marked here with the little angle guys. What's the value of x? So yeah, we're solving for x here, just like we would have thought. And, well, how do we do that? How do we actually solve for that? Well, is there anything else that we can write about this diagram? Well, how about we have two vertical angles here. So we know these two angle measures are the same. And since we know two angle measures are the same in each of these triangles, that means that the third angle measures also have to be the same. Because let's say that, since you know that all angles in a triangle add to be 180, if these two angle measures have taken up, let's say, 135 degrees, these two angle measures are the exact same. They've also taken up 135 degrees, and so you only have a certain remaining amount, and the amount remaining that you have out of that 180 is the same in both triangles. Hopefully that makes sense. So since we know that all of these angles are the same, we have this AAA situation. That means we have similar triangles. And to be honest, you don't even need to go as far as looking at the third angle. If you just find that two corresponding pairs of angles are the same, they're similar triangles. Because then, like we just reasoned, the third angle has to be the same as well. So all you need is two corresponding pairs of angles to be the same. That's all you need for similar triangles. So what does that do for us? Well, that means that we know the ratio between corresponding sides is always the same. So 800, what's the corresponding side there? That's x. So we know that the ratio between 800 and x is equal to the ratio between any other two corresponding sides. We're not going to use 1800 here because we don't know the corresponding side here. And 700, we know the corresponding side is 1400. So we can use the corresponding side there and write that ratio. Now notice that 700's corresponding side is not 1800, and that might be where they're trying to bait you here. That's why they're giving you that number. Think about it here, and if you're ever unsure, think about it. 700 is in between these two angles right here, and in between those exact two angles on the other triangle is 1400. That's how you know it's a corresponding side, and not 1800, because 1800 is between two completely different angles. So that's a good check. And the only other thing I would probably mention here is make sure you don't write this as 1400 over 700. If you're using the smaller triangle in the numerator on one of these ratios, you need to use the smaller triangle in the numerator on the other ratio. Because if you put 1400 over 700 there, you're wrong. And that would be really annoying to get most of this problem correct and just mess it up there. So first off, we know that 700 divided by 1400 is 1/2. Okay, you can just divide each side divide top and bottom by 700 if you wanted. But this is going to be 800 over x is equal to 1/2. From here, you can cross multiply if you want. If you did that, here you would get x, and here you would get 1600. And that is your answer. And with that, we've finished our next set of 5. So at this point, I think it's good to just take a breather, go take a break, drink some water, go stretch or something, and come back, and we'll get our next 5 problems done. But assuming that you've done that, let's get into the next set of 5, and then we'll only have one more after that, and that'll be it for this entire video of 25 harder problems on the SAT. So our next problem here, problem 16, says Alma bought a laptop computer at a store. That you can tell College Board wrote this problem. They said laptop computer. Alma bought a laptop computer at a store that gave a 20% discount off its original price. The total amount she paid to the cashier was P dollars, including an 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Okay, so we are trying to find an expression for the original price. And we know that the price that Alma paid for the laptop, which is P, was that original price, which we don't actually have a variable for. I think that's how they try to trick you in this problem. They don't give you a variable for the original price, and so you just need to make one up. So let's call the original price S. I would call it O, but that's not going to work too well because you're confuse it with a 0. But if we call that original price S, then what happens to this S to make it that discounted price? The price Alma paid. Well, to that original price, we discount it by 20%. And so how do we represent that? Well, yeah, you could say if a discount by 20% multiplies it by 0.8, but where does that even come from? A lot of people get confused with that. The reason why I know that a decrease in 20% is multiplication by 0.8 is because what you're going to start off with here is a 1. And then you subtract that percentage, that 0.2, that's 20% written as a decimal. And how do I know that? Well, you start with that 1 because S times 1 is just S. We're not starting from 0, like S times 0, because then you'd be starting from 0. Right? 0 times S is literally 0. we want to start off from s, and then we want to decrease the value of s by some percent. So we start at 1, and then we say, okay, from there, we want to decrease that value by 20%. So we subtract 0.2. But that's not all that happens to s. Also, we add an 8% sales tax in. And so now we're not decreasing by some percent, we are increasing by 8%. And so this is going to be 1 plus 0.08. We start from s, or we start from, whatever this turns out to be, and then we add the 8%. Okay, so that's why the ones are there. I feel like a lot of people get confused when they see the ones there. It's like, why? But knowing this, we get that P is equal to S times a 0.8 times 1.08. And we're trying to find the expression for the original price. So here we need to solve for the original price. To do that, we divide each side by 0.8 and 1.08. And doing that, we get that S is P over 0.8 times 1.08. And that right there is choice D. All right. Cool. Problem 17. All right, we see the word constant. So what kind of problem do you think this one's going to be? It's another problem with constants, and it's another problem where you're going to have two things equal to each other, where you need to start like kind of crossing off individual pieces like we've been doing in, I guess, problem 2 and problem 14 in this video. So let's actually see if we can pull this all together here. First off, this problem is asking us to find the value of a, and it also gives us this stipulation: x cannot be 2 over a. And could you think you could tell me why x cannot be 2 over a here? Think about it for a second. X cannot be 2 over a here because look at the denominator. It's ax minus 2. If you were to plug in x is 2 over a, then these a's cancel. You're left with a 2 minus 2, and that is 0. So you end up with a 0 in the denominator. This right here is keeping that denominator from being 0. And I guess a little more generally here, generally when you see an inequality in a fraction problem or a not equal sign or whatever, the reason why they're doing that is so that the fraction doesn't have a 0 in the denominator. That's why. But it's really not something you need to worry about when solving these problems most of the time. So generally you can just ignore it. So what are we doing here? Well, what we can do is get all of the denominators to be the same. This negative 8x minus 3 here does not have an ax minus 2 in the denominator, so it's kind of that lone wolf there. We need to get it to have that ax minus 2 in the denominator. And once we do that, we can get rid of all the denominators. Why? Because think of like 3 over 2 plus 2 over 2. We know that that is 5 over 2. That's just how you add fractions. Now these guys all have the same denominator. And what that means is that this equation right here with the numerators holds. It means that 3 plus 2 is equal to 5, and it is. 3 plus 2 is 5. So once the denominators are all the same, then we can just get rid of them. And we can say, well, hey, we know that this is true. And so it's going to clean this up, kind of. All right, so let's multiply this negative 8x minus 3 times an ax minus 2 over an ax minus 2. When we do that, we know that this thing is going to have an ax minus 2 in the denominator, and we're probably going to get something pretty nasty in the numerator. Let's see. We'll have a negative 8x times an ax. That'll give us a negative 8ax squared. We'll have a negative 8x times negative 2. That's a negative 16, or sorry, a positive 16x. Next up, we have a negative 3 times ax, and we have a negative 3 times negative 2. So we get this nastiness, but of course it gets a little bit better because the denominators go away now. We can set this side, this 24x squared plus 25x minus 47 equal to this numerator here, negative 8ax squared plus 16x minus 3ax plus 6. And then we have a minus 53 here. And there you go. So we can combine like terms here. This will end up being a negative 47. And of course you can see it's going to match the other side like this. So this is all the same, except now this is negative 47. So we can actually figure out A pretty quickly here. Remember, we're trying to solve for constants here. We have two quadratics equal to each other. So that means that since this is a 24x squared plus 25x minus 47, this side also needs to be exactly a 24x squared plus 25x minus 47. So the constant pieces need to match up. They do. We both have negative 47 on both sides. That's good. Let's look at the x squared piece, because that looks a lot simpler than dealing with the x's. We have that negative 8a x squared is equal to 24x squared. They need to be the same. So we get a 24x squared on this side. For that to happen, negative 8a needs to be 24. And dividing each side by negative 8, we could see that a is equal to negative 3. And that right there is choice B. Great. So there you go. This problem, by the way, it looks really nasty when you first look at it. And to be honest, it can get a little messy here. But it's not as bad as it looks. Look at our work here. We've done a lot more work for some easier looking problems. All right, problem 18. Here we have that the equation above shows how a temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. Based on the equation, which of the following must be true? And the first thing says, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Now, how do we even figure that out? Where are these numbers coming from? What are they? Well, they are temperature increases. Right? We're increasing temperature here. And so that means we're changing it. And when we're talking about changing something, when we're talking about increasing, decreasing, we're talking about the slope. Because the slope measures how fast we are going up or how fast we're going down. The slope is all about change. And here, this is a line. I don't know if you can see that. Just if you can't, let's multiply that 5/9 through. We get 5/9f minus a 5/9 times 32. You can do that math if you want to, but it'll end up being some number like, let's say, negative 10 or negative 20 or negative 12.2, whatever. But you'll get some number here when you multiply that out. But see how this is already in y equals mx plus b form? Change the c to a y and change the f to an x. You see how this is exactly in y equals mx plus b form? The b is this guy, and the m is this guy. That's the slope. That's what we're keying in on here. And of course, we know that the slope is the change in y over the change in x. But here, that y, there's a c in that spot. And in where there would usually be an X, now we're seeing an F. So the slope here is the change in Celsius over the change in Fahrenheit. So here that slope is 5/9. And that means for every 5 degrees Celsius that we're increasing, we are increasing 9 degrees Fahrenheit. Okay? And this first statement here says that we're increasing the temperature by 1 degree Fahrenheit. So we need to get this thing to be a 1. And how are we going to do that? Well, let's divide each side. Let's divide top and bottom by 9. That will give us 1 degree Celsius, or sorry, no, that'll give us a 1 degree Fahrenheit in the denominator, and that will give us a 5/9 degrees Celsius in the numerator. So for every 1 degree Fahrenheit that we increase, we're increasing by 5/9 degrees Celsius. And that's exactly what this says. So statement 1 is definitely correct. Oops. And so since that's true, we know the answer is definitely not B or C. And definitely make sure that you're marking off your answers as you're going about this, because a lot of the times you won't have to check all these statements. You only need to check 2 of them if you're using process of elimination. So now we just got to figure out whether this statement 2 is correct, and if it is, then we know that the answer is D. If it's not, then we know the answer is A. Statement 2 says that a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. And just doing that out here, we again start with 5 degrees Celsius over 9 degrees Fahrenheit. Now we are increasing by 1 degree Celsius, so we divide top and bottom by 5. And so we get that for every 1 degree Celsius we are increasing by 9/5 degrees Fahrenheit. That 9/5 comes from the 9 divided by 5, in case that's unclear. Now what is 9/5? Is that 1.8? Yeah, it is. So statement 2 is correct, and this is green, right? Yeah. Choice D is going to be the answer here. And just in case you're having trouble doing 9/5 in your head here, 10/5 is 2. And so 9/5, when you're dividing something by 5, you're going up in 0.2s. 1/5, 2/5, 3/5. This is 0.2, 0.4, 0.6. And so just 9/5, I naturally know to decrease it by 0.2. I gotta admit, it's very challenging for me to explain how I just kind of throw things around in my head mentally, but that's it. So, yeah. That's it for problem 18. Problem 19 says that a group of friends decided to divide the $800 cost of a trip equally among themselves. When 2 of the friends decided not to go on the trip, those remaining still divided the $800 cost equally, but each friend's share of the cost increased by $20. How many friends were in the group originally? So, look, here we're going to probably get some kind of equations here, and it's going to be, it's a little bit difficult to try to sometimes like convert words into math. That's the hardest part of this problem, because if you do this, then you get a system of equations which you can then solve. And the system of equations part really is not nearly as hard as converting the words to math. So see if you can do the words to math part, and if you can, then you're well on your way. So, to just start off here, this group of friends is deciding to divide the $800 cost equally among themselves. And so, what does that actually translate to in math? Well, this group of friends, they're taking this $800 cost, they're dividing it by the number of people in that group, and they're each paying some amount of money. That's really what's going on here in the world of math. But then what happens is two of these friends decide not to go on the trip. And so how does that affect this equation? Well, now this number of friends is going to decrease by 2. And then the question is, well, what happens here to y? What happens to the amount that each of them pay? Well, they're still dividing the 800 cost equally, and now each friend's share of the cost increases by $20. So y increases by 20. And just so you are keeping with this here, maybe I should just draw this on the side here. X is the number of friends, and y is the original cost per person. And I guess I should add here that X is the original number of friends. You don't have to, of course, write that when you're doing your SAT. I just want to make sure that I'm communicating this clearly to you. That's very important because, well, I'm recording a YouTube video at the moment. So at this point, now you have your system of equations. You have 2 equations, and you can use that to solve for one of these variables. The variable that we're trying to solve for here is how many friends were in the group originally, aka X. So if we're trying to solve for X here, then honestly, we already know what y is. Y is 800 over X. Let's plug that into this equation. We get that 800 over X minus 2 is equal to 800 over X plus 20. And now we have to get common denominators. So how do we end up doing that here? What's the common denominators? Well, we would have to have an x times an x minus 2, because we can't just like subtract 2 on top and bottom. That's not how this works. You can't do that. You can multiply the same thing on top and bottom. You can divide the same things on top and bottom, but you can't just go and subtract like weirdly like that. So this thing is going to need an x. So it has the x that this one does. This guy is going to need an x minus 2 over x minus 2. So it has the x minus 2 that this one does. And then the 20 over here doesn't have either of those. It doesn't have the x or the x minus 2. So that's got to go on top and bottom. Okay, now that these guys are all going to have the same denominators, these denominators are going to go away. And so I'm just going to write the numerators here. On the left-hand side, we're going to get an 800 times x from these two. On the right-hand side, we'll have an 800 times an x minus 2 plus a 20x times x minus 2. And so we can already see here that this will become an 800x. So like these two will end up canceling off. But you also have to distribute that 800 through to the negative 2. And that's a negative 1600. Then we have a 20x that we need to distribute to the x. That'll give us a 20x squared. And then we have that 20x that we need to distribute through to the negative 2. That'll give us a negative 40x. So like I said here, if we subtract 800x on both sides, that will go away. And on the left-hand side, we're left with 0. On the right-hand side, we are left with 20x squared minus 40x minus 1600. At this point, we can divide each side by 20. Because let's reduce this. We don't need to plug this giant number into quadratic formula. And also it wouldn't help because, oh, I guess this is a calculator problem. But still, it's just not fun to do that. So on the left-hand side, we get 0. And on the right-hand side, we're going to get an x squared minus a 2x. And then 1600 divided by 2, that is going to be an 80. Just thinking about that here, this 0 cancels out with this 0. It's 160 divided by 2, which is 80. Now we need to factor this. What are two numbers that add to be negative 2 and multiply to be negative 80? This might seem a little daunting at first, but think, we're just trying to find two numbers that are 2 apart. They're 2 apart so that you'll get a 2 out of it, and they multiply to be 80. And I guess the first thing that comes to mind is 10 and 8. 10 and 8 are 2 apart, so we can get a -2 here. We'll start by making the bigger number negative, so we'll end up with a negative number, and then we'll put the 8 here. And of course, -10 plus 8 is -2, and -10 times 8 is -80. So we've done our job. That means that x is equal to 10, and x is equal to -8. And of course, we can't have a negative number of friends unless you're me, but here we're assuming these are normal people, and that they're sociable, and so the answer here would be 10. So that is the answer for this problem. It takes a little bit of work, takes a little bit of, finding common denominators, all that stuff, but hey, we got the right answer in the end. That's all that matters. All right, problem 20. This is the last problem for this set of 5, and then you can take a break. This problem says a rectangle was altered by increasing the length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what is the value of p? So we're talking about a rectangle here. That didn't work. We're talking about a rectangle here. Yeah. And this rectangle is going to have some length and some width. It also has some area. And, when we're talking about math problems here, we need to have some way to relate all of these things. And how do we relate area and length times width? Well, I just gave it away. It's area equals length times width. We know that. But now, what's happening? Well, we're taking this area, starting from the left, we're taking this area here, and we are decreasing it by 12%. So this area, we start off with that 1, okay, because we're starting from the original area. A times 1 is A. And then we are subtracting the 12%. That's going to be equal to the length times, we are increasing the length by 10%, so we go 1 plus 10%. Then we're multiplying that by the width times, well, it's decreased by p%, so that is a 1 minus p%. This is not a decimal though, that's a percent, so we need to divide it by 100. It would be really nice if I could just write that as like 0.0p or something like that, but that just doesn't make any sense. I don't know, maybe that only makes sense in my head. But yeah, anywho, what can we do with this now? Well, let's simplify a little bit. This is a times 0.88 is equal to an L times 1.1, or actually I'll just write LW. I'll group these two variables together. We have a 1.1 here from this, and then we have a 1 minus p over 100. Now the problem here is that we want to solve for p, but we have 4 variables here. We have the a, the LW, and the p. So how do we get rid of the a and the LW? That's the question that you need to be asking. And maybe you can see it already, not sure, but you realize that area is equal to length times width, right? So why don't we divide this side by a, divide this side by LW, and now we have gotten rid of the a and the LW. Why can we do this though? Isn't this illegal? We divided by different things on both sides. Well, yeah, they may look different, but they're the same. They're equal. So we divided by the same thing on both sides. So we can do that. It's illegal. We're not going to, the math police isn't going to show up. We're good. I just said the math police in a YouTube video. Oh dear. I just said oh dear in a YouTube video? Yikes. Anyways, we're dividing here by 1.1 on both sides. You could do that in your calculator. 0.88 divided by 1.1 is, I think, 8, right? Something like that. No, it's like, what is it? I'm completely wrong. It is 0.8. Yeah, of course. Why did I not get that? And this is 1 minus p over 100. So then what we can do is we can just subtract 1 on both sides. And then we get negative 0.2 is equal to negative p over 100. Solving for p here, all you have to do is multiply each side by negative 100. Then the negatives go away, and the 100s go away. And so we're left with p on this side. Of course, we have to multiply the other side by negative 100. That'll give us that p is equal to, this is a 20. So p is 20%. And 20% is choice C. All right, so that is it for our next set of 5. So again, take a break, go stretch, go like take a walk or something if it's not freezing outside of your house like it is for me, and just enjoy life for a second, and then come back and I don't want to say not enjoy life, but like. So getting into the first problem for our last set of 5 for this video, we have a table problem, and this problem says the incomplete table above summarizes the number of left-handed students and right-handed students by gender for the 8th grade students at Kiesel Middle School, I don't know. There are 5 times as many right-handed female students as there are left-handed female students, and there are 9 times as many right-handed male students as there are left-handed male students. If there's a total of 18 left-handed students, and that's right here, and 122 right-handed students in the school, which of the following is closest to the probability that a right-handed student selected at random is female? It says assume that none of the 8th grade students are both right-handed and left-handed. Yeah. So how do we do this? I mean, what goes here in this table? It's blank. And what are we even trying to find? Well, we're trying to find the probability that a right-handed student selected at random. So like, we just select a right-handed student at random. What's the probability that that student is female? That's what the problem is asking us. And so cool, we get that direction. But we need to know how many right-handed female students there are to actually figure out that probability. So we have to use some of the other information in the problem. That being, first, that there are 5 times as many right-handed female students as there are left-handed female students. So how do you write that with math? Because that's really what this problem is about, right? How do you write this with math? Well, if there's 5 times as many right-handed students, then if there is x left-handed students, there is 5x right-handed students. Similarly, for males, there's 9 times as many right-handed male students. So if there is y left-handed students, there would be 9y right-handed students. And so maybe you can see what's about to happen here. We're going to be able to solve for x and y. And of course, all we need to do actually here is solve for x, because then we'll get the number of left-handed or the number of right-handed female students. So just figuring this out here, how do we actually calculate x? Well, we do know that there's 18 total left-handed students, and that will be x female students and y male students. We can add those together to get 18. We can also see that there is 5x plus 9y, or 122 right-handed students. And now we have a system of equations. So that's what this problem is. Now keep in mind here, we are trying to find x. So a good idea, if we want to use substitution method, which I think that would be better here. If we wanted to use substitution method, then we should solve for y here, so we can eliminate y. Y, if you just subtracted x on both sides for this equation, y would be 18 minus x. And then we can just plug that in for the y here. Now this is a calculator problem, so you can use your calculator if you want. I don't know if we'll need to here. We'll have 5x times 9 times y is an 18 minus x. as per this guy. And this is equal to 122. Now, this ends up being 5x plus, this is a 9 times 18. You can do that mentally. That's just 9 times 9 plus 9 times 9. Right? This is just going to be, that's how I would think about it at least. So it's 81 plus 81, and that's 162. And I'm trying to figure out a way to explain how I know that. If it's 9 times 18, then I know this is double 9 times 9. That's just how I think about it. So then you have to distribute that 9 through to the negative x, and that'll give you a negative 9x. And then that's equal to 122. So we get negative 4x, and that's just combining like terms on the left-hand side. And then we also should just subtract 162 on both sides to get the non-x pieces to the right-hand side. Doing that, we cancel off this, we'll end up with a negative 40 here, and that'll mean that x is going to be 10. You can see that if you divide by 4 on both sides, or you kind of just think about it from here. So we get that there is 10 left-handed female students. And that means that there is 50 right-handed female students. And so we get this. Of course, what are we actually asking for here? We're asking for the probability that a right-handed student selected at random, which there are 122 of them. We're asking what's the probability that that student is female? And well, there's 50 female students that are right-handed. And so 50 divided by 122, that's something you'll need your calculator for. That is 0.410 once you round up. Because I think when you put this in your calculator, you get 0.4098, and you'll have to round that up to a 0.4110. Or a 0.410. So that right there is the answer, and that's choice A. And to be honest, that might be one of the harder problems of this last set of 5 here. It really doesn't get too much more difficult than this. This is just a kind of quick system of equations. It gets a little gross, but of course you have your calculator. You can also, since you do have your calculator, you can just plug these into your calculator. You would have to convert them into y equals mx plus b form, so by then it might not even be worth it. But you could do that and then graph them, and then you would get that x, you could find the intersection of them. The x coordinate of the intersection would be 10. So you can do that if you want. All right, moving on to problem 22 here, we have that in the figure above, point D is in the center of the circle. Line segments A, B, and BC are tangent to the circle at points A and B respectively, and the segments intersect at point B as shown. If the circumference of the circle is 64, okay, C is 64, what's the length of the major arc AC? Now, the major arc AC is not this. That is the minor arc AC. I think that would be a big mistake a lot of people made with this, and that's why I'm glad I'm bringing this up. The length of the major arc AC is the larger arc that connects A and C. That's what we're actually trying to find the length of. But honestly, since this, like, we have essentially have a quadrilateral here, it's focused around this arc here. What it might be easy to do is find the length of this arc and then subtract it from your circumference. Because if you take the circumference of the entire circle and you subtract out this piece, you'll get exactly the length that you were trying to find. So that's what I'm going to do here. I'm going to find the length of the minor arc AC first, and then I'll just subtract it from the circumference of the circle. But the question is, well, how do you actually find that arc? Well, we're going to need this angle here. And why do I say that? Well, because I know that with the circle problems involving angles, they're talking about proportions here. You're going to have to deal with some proportions. And what are those proportions? Well, in a circle, area which we're not dealing with any areas here, but area is proportional to angle, central angle, and that is proportional to arc length. What that means is that these guys right here will all have the same ratio, and I'll show you that. It's a very quick explanation. Let's say I have a circle here, and I have traced out a quarter of this circle. You can see that from the angle. The angle is 90 degrees, and we know there's 360 degrees in a circle. So the central angle is 1/4 of the entire circle. I have also now created a space for 1/4 of the entire area. This is 1/4 of the area of the circle. And it is also, this length right here is 1/4 of the circumference. So these guys all have that same ratio. And it's very easy to see when you look at it that way. What that means is that, and you can write an equation here, that we'll call this the sector area. The sector area divided by the area of the circle, the entire area, that ratio in this case is 1/4. That is equal to the ratio between the central angle and the, 360, the total angle of a circle. And then that is going to equal the ratio between the arc length over the circumference. Here that is 1/4. The arc length here is 1/4 of the entire circle. So this is an important little equation to know, and I've definitely went over this a couple times with circles before. We definitely touch on this a lot in my SAT course because this is huge. Like, this is really important to know. And so, I mean, what does this help us with here? We don't have any areas. We're not dealing with this. So we need to focus our attention right here. Now, 360 is known. We know the circumference. We are trying to find the arc length here. We want this. So we need the central angle, like I was saying, and that's how we know. The issue is, how do we find this angle? And, well, to do that, I mean, maybe you'd think, oh, we have this quadrilateral here, and we know this angle, so maybe we can figure out what this angle and this angle are. And that'd be exactly right. How do we know what those angles are? Well, you might just be able to see it just by looking at it, but we're given in this problem that segments AB and BC are tangent to the circle. And what that means is that they form a right angle. They form right angles right here. And that means they're 90 degrees. So we know that this angle here, we can find that, we'll just call it X. If we add up the internal angles, that's going to have to be equal to 360. That's the total, that's the sum of all interior angles in a quadrilateral. And we'll just solve for X here. 90 plus 90 plus 45, if you work out at all, you should know this. That's 225. And the reason why I say that, that's just bench press, right? If you have your barbell and then you put 2 plates on each side, you have a 225 bench. So only like 10% of you, or maybe like smaller percentage of you, will appreciate that. But I'm just saying, you have no excuse not to know this stuff if you work out. Anyways, we get here that X is 135. And from there, we can use this ratio to find our minor arc. We know that we have traced out 135 out of the entire 360 degrees in the circle. And so this arc length is going to be something out of 64. And that ratio is going to be the same. So Right here, you can multiply 64 on both sides, or you can just fully cross multiply, but that's going to take a little bit longer. And then solving for x here, just plugging that into your calculator, you'll get that x is 24. Or maybe I should. Let me use a different variable here. Let's call this y. And y is going to, that's what I'm using for this arc, because I've already used x, so I'd like to use a different variable now. So we get that y is 24, that's the length of the minor arc AC, but we're asked for the major arc AC. So let's subtract that from the entire circumference. If we have our entire circumference, we take out this piece, we'll get this piece over here. So 64 minus 24 is 40, and that is the answer for this problem. Great. All right, problem 23. This is definitely a problem people have, like when they're talking about systems of equations where we talk about no solutions, infinite solutions. People generally tend to have some trouble, so I definitely wanted to put one of these on here. It says, in the system of equations above, x and y are variables, and q is a constant. For what value of q will the system of equations have no solutions? So you got to understand what's even going on here when we solve a system of linear equations. A system of linear equations, remember a system is when we have multiple equations. Linear means we're dealing with lines, so it's multiple lines. And when we have a system of equations, we generally ask for the solution of them. And so what you need to know is that when we have two lines, they can intersect once. That's one possible way, and this is generally what you'll see. This is the most common, is one solution. But these lines don't have to intersect. They can be parallel to each other, they can have the same slope. And that would mean that they never intersect, and that's no solutions. There's no intersection point. And then there's infinite solutions, which means that these lines are directly on top of each other. Okay? And maybe I'll just make that clear. I'll turn it back green. But yeah, you have lines on top of each other. And that is infinite solutions. Actually, I have an idea for how I can show that even better. Watch this. Watch this magic about to unfold. So we're going to color that blue, right? We're going to change the thickness of this guy. We're going to make it a thick boy. And then we are going to use the green, and then we're going to draw a little line in it. There we go. See, now you can clearly see that there's green and blue there. So that is two lines on top of each other. And that is infinite solutions. They intersect at every single point. All right, great. I am really, really impressed with that. Anyways, here we have no solutions. That means that these lines don't intersect. And how I like to solve these problems is, well, if we know there's no solutions, that immediately tells us that they have the same slope. They'll have the same slope if there's infinite solutions too, but that's not the case that we have here, or that we will have here. So if they have the same slope, then what we can do is we can put each of these equations into y equals mx plus b form, and we can set the slopes equal to each other because we know they have to be the same. So let's do that. Let's take this qx minus 5y equals 6. We'll convert that into y equals mx plus b form. And that might actually help you too, because you might not realize that these are lines. Okay, they have, yeah, sure, they have x's and y's to the first power, but it's hard to visualize exactly how these are still lines. So you'll see that here. So I'm going to subtract qx on both sides, because I'm going to get the x's away from the y's. So here I'll get a negative qx plus 6. I'll write it like that so it looks like, mx plus b. And then I'll divide by negative 5 on both sides. And that will make it this y. And, whenever I divide like this, I don't know if this ever confuses you, but you can just write it like this. And I think that's how a lot of people write it, just to eliminate any confusion. this ends up being a q over 5x minus a 6 over 5. And then just doing the same thing with our other line here. This is a 6x minus 7y equals 5. For this one, I solve it in the exact same way. I'm going to subtract 6x on both sides to again, start getting the y by itself. This will be a negative 7y is equal to, I'll write this as a negative 6x plus 5. Then I can divide negative 7 on both sides, and you can write it like this, or it might even be clearer, like I was saying earlier, to write it like this. Kind of feel bad for not writing it like that now, just in case anyone got confused about that. But y is equal to 6 over 7x minus 5 over 7. And again, you can write this x in the middle here, or you can write it in the numerator. It's really up to you. But I like to write it like this, because then you see where your m is, you see your x, and it's like clean. But as I was saying, there's no solutions here. That means these lines have the same slope. And so if the lines have the same slope, then q over 5, the slope for this line, is equal to the slope for this line, 6 over 7. Then you can just multiply 5 on both sides here. And that'll give you that q is 30 over 7. And that is the answer for this problem. So it's not too bad if you really understand what's going on with systems of equations. You know, the big thing is when they talk about no solutions or infinite solutions, you got to understand that if you have no solutions, the lines have the same slope. Same thing with infinite solutions. This problem could have said infinite solutions instead of no solutions. We would have solved it in the same exact way. If the lines overlap, they still have the same slope. They're still going in the same direction the entire time. And so if the slopes are equal, we set them equal. To do that, we got to find them first, but we set them equal, and it's pretty easy to solve from there. So that's all this problem really entails. All right, problem 24. This is definitely a problem that I know people would look at and just be like, no, I have no idea. We never learned gears in algebra class. And look, this is why on the SAT they'll give you stuff like this, stuff that you've never seen before. And they'll just be like, okay, go and solve this, and you'll be like, I've never seen this. So honestly, when they give you problems like these, you can use what you've learned already. It's just a matter of trying to apply that knowledge to a completely different problem that you haven't seen before. But that application is where a lot of people get freaked out. They don't even think about that because they're too busy saying, well, I've never seen this in my class before. So to solve this problem here, well, actually, maybe I should read it first. I think that would be a great place to start. It says a gear ratio, R to S, is the ratio of the number of teeth of the connected gears. The ratio of the number of revolutions per minute, RPM, of two gear wheels is S to R. In the diagram below, gear A is turned by a motor. In the turning of gear A causes gear B and gear C to turn as well. If gear A is rotated by the motor at a rate of 100 revolutions per minute, what is the number of revolutions per minute for gear C? So we're asking, what's the RPM of gear C? And we're given that the RPM of gear A is 100. So this problem really is not very strenuous. Okay, we know what it's talking about ratios here, and we know the ratio of this gear to this gear is 1 to 3. How do I know that? Because this one is 20 teeth, this one is 60 teeth. That is a ratio of 1 to 3. And you can even just see that this has 20 teeth. It is 3 times smaller than this gear. It will spin 3 times slower, or actually, sorry, 3 times faster than this gear, which will, spin 3 times slower than this gear. So that means that if this one is spinning at 100 RPMs, this one is spinning at 100 over 3 RPMs. And gear C has 10 teeth and this has 60 teeth. So this is 6 times bigger, it will spin 6 times slower, meaning that this will spin 6 times faster. So take this 100 over 3 and multiply it by 6. And that is this 2, this is a 1, that's 200 RPMs, which is choice C. Now look, there's a bunch of different ways that you could have like thought about this. I kind of did more of like a back of the envelope thing, like everything I just did was extremely messy, but sometimes that's how these problems will be. Your work will be messier, and just as long as you understand it, that's the whole part. That's the important part. But as far as this problem goes, there is a quicker way that you could have solved it, and that is that gear B doesn't even need to be factored into this equation. We don't really care about gear B. You could have just connected gear A and gear C, and you could have got the answer. Look, gear A is twice as big as this gear. That means that this gear is going to have to spin twice as fast to keep up with this gear. Or, I mean, I guess the gear will just spin twice as fast in general. I'm probably not wording things perfectly. So if the gear spins twice as fast because it's twice as small, then you're going to get 200 RPMs instead of 100 RPMs. You just multiply it by 2. And that's the exact same thing that we got here. So gear B it's not going to, like, the addition of gear B does not speed up or slow down gear C. It's just a connecting piece. So it's not affecting our answer. We could just think about this directly from the ratio from gear A to gear C. But honestly, this is such a quick problem that it really doesn't matter too much if you factor in gear B. You're going to lose maybe 5 seconds. Like, it's not that big of a deal. Last problem here. And I think this is a good problem to end on. See if you can get this one. It says, the scatter plot below shows the amount of electric energy generated in millions of megawatt hours by nuclear sources over a 10-year period. So whatever. Okay, cool. We see this thing here, and we're given a bunch of quadratics that could model it. And we're saying which one best models it. Well, how are these answers different? I think that's a great way to, because I mean, all of these are equations that are trying to represent this. What are the differences in these answers? There's only a couple. They have the same numbers. It's just some are positive and some are negative. Now, the piece, and this is something I think a lot of people don't understand. This is the y-intercept of these quadratics. The y-intercept of a line is the b. And I think most people understand that. But with a quadratic, a lot of people don't understand the y-intercept of a quadratic is c. Why? Because the y-intercept is this, it's on the y-axis. The y-axis is the line x equals 0 because we haven't moved right or left at all in the x direction. So we want to find the y-intercept. We look at where x is 0. If you do that for a line, plug in 0 for x, you get m times 0 plus b. That means y is equal to b. That's your y-intercept. That's the y value at x equals 0. But plug in 0 here for x, and the only piece that's not affected is the piece without the x. So the y at x equals 0 is c. That's the y-intercept for a parabola. So that's what this quantity without the x means. That's what it always has meant. It just is sometimes a lot of people lose that. And so what's the y-intercept here? Well, just kind of roughly, modeling this quadratic here. The y-intercept is somewhere around, it says here 745. It's a positive 745. It's not negative. So we already know the answer is definitely not A or B. That leaves C and D. What's the only difference between C and D? Well, how about that C has a positive 1.674 and D has a negative 1.674. So what does that positive or negative tell us? Well, if a parabola is opening upwards, that means that it has a positive number in front of the x squared, whether it's a 1, a 3, a 5, a 2, whatever. If the parabola is opening downwards, that means you have some negative number in front of x squared, whether it's -1, -2, -3, and so on and so forth. And so is our parabola opening upwards or downwards here? Well, it's opening downwards. This one looks like this one. So that x squared is going to have a negative in front of it, and it does in choice D, it does not in choice C, so choice D is our answer. And so that is going to do it for all 25 of these harder SAT problems. Now again, the goal of this video was not to find the hardest possible SAT problems that anybody could ever imagine. The goal was to find 25 problems that were, a little bit harder than average, that you generally can't solve in like a couple seconds, and show you how to go through these problems, some different things that you might not know you need for the SAT, to review different things like we reviewed exponent rules, systems of equations. We reviewed a lot of these finding constants when you have two quadratics equal to each other. And so that was the goal of this video. Now, I'm sure that at one point in this video you had some kind of question. Maybe you had a couple questions. Ask them in the comments and I'll try to get to them when I can. But yeah, I hope this video was able to help you guys. Definitely check out my full SAT course for more. And if this video did help you guys, definitely consider subscribing, because at the moment only about 6.9% of you that watch my videos are subscribed. And I know you guys think that's so funny, but like, I'd like to hit 100K. That'd be amazing. So if this video was able to help you, definitely consider subscribing. But yeah, guys, that's going to do it for me. Good luck on your SATs, and let me know, of course, how you do, and I'll see you soon.